today we're going to use the Geometry app in the FXCG500 Casio Graphing Calculator to show you how to construct isosceles triangles. So I have right here the calculator. I'm using the emulator, and this version or this particular view of it looks just like the handheld. So if you have students who have this calculator, they can follow along with the steps that you're doing because this looks exactly like it. I am going to pop it out into the emulator mode that is called resizable, mainly because it allows me to show you the images much larger. So I'm going to do the first triangle in the normal mode that would match what a student might have. The nice thing about this calculator is it does have a very large window. So this is the window with the menus, and I can use my mouse when I'm in the emulator. If the students have a stylus or their finger, that's what they can use to, toggle between things and select items. So I'm going to select the geometry menu, and I've done a previous video that showed you how to change settings and what each of these little icons and symbols mean. So we're just going to dive right into constructing isosceles triangles. So if you just want to have an isosceles triangle out there really quick, not waste time, but not take the time to go through the construction of it and think about its properties, the easiest way to construct it is to either go to Draw and go to a special polygon, and you'll see that isosceles is an option here. You can also see that same option in this window right here. If you scroll down, there's a picture of an isosceles triangle. So either way, they do the same thing. They're the same menu item. So I'm just going to click this, and notice it now shows that that is selected, isosceles, and the minute I hit something on the screen with my mouse or my stylus, it draws or constructs an isosceles triangle. So if this is what you want to do, if you want to get right into it, this would be the most efficient way to get to an isosceles triangle, and then you could measure the angles. And let's just briefly show how to do that. So we're going to measure this vertex angle here, and once I select it, I go into the Draw menu and choose Measurement, and I want to measure the angle, right? So there's my angle measure. And as I move it, and so I could measure now all three of my angles by going through that process. And it didn't like that because I had the measurement selected, but let's measure again. And I'm just moving that over, and let's measure this last one, because what is it we want students to understand about the angles of an isosceles triangle is that the base angles have the same measure. So I see that now. I say, oh, isn't that interesting? Is that true if I change the triangle? So let's select one of the vertices, and notice it's selected, highlighted. Now I can hold my mouse down and change this. So let's change it. It's still isosceles. I know that because of the tick mark. So these two sides are congruent. I can measure those sides just to be sure. So we can select and measure the length. So I don't know why it's saying the length is 0, so I think I must have had something else selected. So here's where Edit Undo is a really nice feature. So let's try that again. Let's measure my length. There's a length. That's my base. Let's measure this length. So measuring is pretty easy. You simply select what it is you want to measure, go to the Draw Measure tool, and it will measure it. Now, if this is isosceles, what I should know because of those tick marks is that this AB segment is going to have the same measurement as the BC segment. Let's just verify that, and it does. So now, this is pretty quick. If you used the isosceles triangle tool, you made an isosceles very quickly, and now you can just do comparisons and move things around. So that's one way to construct or draw an isosceles triangle. But another way, and here's where I'm going to pop out and go into the larger screen view. So to do that, I right click and I choose this resizable mode, and it's going to pop out for a minute and it's going to come back, and now that screen that I was working in is much larger. I can actually change the size to fit whatever screen I happen to be on. And it looks a little silly right now because the thing that I had constructed before is off screen. And here's where you can go into view and use your zoom options. And so I'm going to zoom to fit here. So now this original triangle that I had is available for me. And I'm just going to move it off to the side here because I want to show you how I can construct an isosceles triangle a different way, actually using the properties. So maybe you use this one to discover the properties, right? You can move this and change it. And one thing that's nice in this view that is much easier to do when I have this angle, so notice this angle has to do with, I don't even remember, oh, this is a vertex angle, so it's this angle B. It doesn't have a label and it's hard for me to follow. So I could actually go up here and change this so that now, or maybe I want to, let's just say angle B. And now I can clarify which one is which. And so that's a nice thing. I like this view better just because it's easier for me to, you know, edit measures, add labels in that I might want, because I definitely want students to be following along with, you know, which measurement is actually corresponding to which angle, those types of things. So I can manipulate and move those and edit those right in this view. A lot simpler. Not that I can't do it in the other view, but this is much simpler to do in this view here. And I could do the same thing here, but with the side lengths, but I'm not going to do that right now. So I've used the tool quickly. So let's say now we've discovered, oh, isosceles triangles must have the same two sides the same length, at least two sides, sort of depends whether you're doing exclusive or inclusive. But another way to construct is to actually use those properties. So if I know that I have to have two sides the same length, what construct, what shape allows me to create congruent lengths right away? And you think about a circle has the radii. All the radii in a circle are congruent. So I could use two radii in the same circle, and that gives me two congruent lengths. And then I simply then connect the points of those radii together to get my third length of my triangle. So here's where I can go in and use my circle tool to help me construct an isosceles triangle. So I'm going to make a circle. There's my circle. And now I'm going to use my segment tool. So I can either get that by going to basic objects and choosing segment, or I could have gone here and chosen segment. So let's make a segment from the center point to the circle. And then let's make another one. And let's make it go out to E, which is also. So there's two radii, which I automatically know are congruent because they are the radii of a circle. So now I just need to connect these two here, and I have another version of an isosceles triangle. And if I put the tools away, it'll do the same thing, except now my circle is controlling it. But it's a nice connection to using prior knowledge about circles to help you construct other geometric constructs. And so I could now verify that these two sides have the same measure by selecting them and measuring their length, right? So that length is 33, and this one, if I am using my properties correctly, this should also have the exact same length, which it does. And I could again label them if I want. I could now add in text. So this is a nice thing about this having this big space here. I can actually add in text, which you can do in the other one, the smaller version as well. I just like the ability to do that here. So I can draw text, and I can say, well, here's what I've discovered about isosceles triangles. They have at least two congruent sides, and base angles are congruent. And so when I hit OK, now I have that description down here that I could add to my document. Oh, I made it go off the screen. So those are the two different options for constructing isosceles triangles, letting the computer do it with its special tools, its special triangle tool, or using properties and using circles and constructing that way. Now, there are obviously many more ways to do it. You could use reflections, the bisector of the perpendicular bisector of this segment and a side, and then reflect it over that line. There's lots of ways to do it, but these are basically the two most efficient ways to do this.